Good afternoon, sir. I'm Man Lok. In this project, I'm handling the data connection and data transfer part. First, I will talk about the data connection part. Let's take a look at the material list. In this part, I will use the water flow sensor, Raspberry Pi 2 Model B, and some of the jumper. At the below picture, there are the Raspberry Pi and the water flow sensor. To the connect part, water flow sensor has 3 pins. One is 5V and another one is ground, and the last is 0. And I connect it to the 5V ground and general purpose input output GPIO pin to the Raspberry Pi. In my case, I'm using the GPIO pin 7. About the sensor to connect the data, actually, you can run the program and then insert the water by the phonets, but it is hard to confirm how many water pour to the sensor. So I prepare a bottle of water that have an approximately volume, and I measured about 300 ml in the demo video. Then run the program and pour the water. Make sure that the water pouring is needed to follow the direction, and it can be confirmed by the arrow behind the sensor. Now move on to the data transfer part. I have used the Raspberry Pi 2 Model B and network to achieve that. Before talking the result, I would like to talk about the presetting first. On the server part, it is needed to create a project on the server, then create a register ID and device ID. On the device ID, it is needed to share the public key that generated from the Raspberry Pi. On the Raspberry Pi part, it is needed to generate the public key and the private key. Also download the root certificate from the Google. After that, it needs to set the follow path of the private key and the root certificate in the program. Also, the project ID, register ID, and device ID is needed. After finished the above presetting, it should success to connect the server, furnish the message. Here is the result of 2 parts. The first line and second line is the sensor sends the value after conversion. The first one is in every second, and the second one is the total. And the third line is the message format. It is composed from the sensor ID converted value every second and the send time. The fourth line is about the connection success or not. In here, I only list out the success cases. The last line tells us that the message has punished to the server. That's all of the data connection and data transfer part. Now pass the time to Jason.
So thank you, and now I'm going to talk about what we are going to do after we collect the data from the central controller. And here is the data management system. As you can see, after the central controller collect the data from the Raspberry Pi, it will send the data through the message bus with the MQTT protocol to the cloud pub and sub. And when the cloud pub sub receives the data, it will trigger an event which will start the data processing from the cloud function. Once the cloud function is start the data processing, the data will be inserted into the database. And our web application could access the database by sending the request to it, and they can access the data and get the information. So here is how the data transmission works. The transfer data from the central controller to the server through the MQTT protocol. Here there will be 2 keys for the to identify the device. One key is for the device, and one key will be for the server. 2 keys will be matched, and the data can be transferred by the MQTT protocol. Once the data is sent to the cloud pub and sub, it will trigger the cloud function, and then the data processing will be started. And here is my Python program of the cloud function. In this part, the message will be split into 2 parts into different attributes for the database. One is the device ID, and one will be the data value. Also, my function will start to record the time, and the time will also be sent into the database as well. And for the database, we choose to use the BigQuery. It's the database function from the Google Cloud service. This BigQuery to store the data, and also our web application can access the data through the BigQuery, and is wrapped with the standard SQL, so it is very convenient for the developer. And here is the structure of my database. There will be 4 tables in my database. First will be the device table, and second will be the user table. For these 2 tables, if the data will be stored by the default, but not by the sensor or the function we just talked about. And as you can see, there will be a device ID, device type, and device name for the device table. The device ID will be the unique ID, so every device will have different device ID. And for the device type, there are 2 types of the sensor we are using, and one is for the electrical sensor, and one is for the water sensor. The device type could identify which type is it. But for the user table, the user ID will also be the unique, and since different user will holding different kind of device, so from this user table we can know which user is holding which device. And for the third and the fourth table, it would be the data table. The data will be collected with the sensor, and it will be inserted by the cloud function as I mentioned before. As you can see, we can record which device is collected, how much data is used, how much water is used, and also the time of the recording will be inserted by the cloud function as well. So here is the result of my part. First, the message is received from the cloud pub and sub, and here it shows that the message is received. Once it's received, the data processing will start, the cloud function will start working, and here you can see the data is inserted successfully, which means the function is executed well, and the data is successfully inserted into the database, just like this figure shows. And that's the end of my part. Thank you, and now I'm going to pass my mic to my next groupmate to talk about the web application. Thank you.
Okay, now it's about the website design. So on the picture on the right, so it is the site map of the website. So the first page will be the login page. So the user need to log in, and afterward with the home page, it will show the summaries of both power and the water chart. And for each resources, they will have their own chart and device page to show the individual device, the chart of the individual device, and to manage the device. And lastly will be the account page. So the login page is implemented for the security feature, so it requires the username and password to enter the website. So the login page will deny the access for the user who entered the wrong username and password combination. So in this project, we only use one account for the demo. So after the user enter the correct combination, so they will land in the home page. So it will show the water and the power consumption for all device, and there's a sidebar in teal color, so it will have the link jump into different pages. So for the chart page, it will show the data of all the devices. If the user have more than one devices, so the page will show multiple charts. And for the device page, the user can manage their device in this page, so they can see how many devices they have added into their account, and they can also add device by entering the new device and their new name. Also, they can delete the device by pressing that button. For the website style, so I use the materialize as the style. It is a external CSS style sheet. So he have the predefined style for the layout, the buttons, and the other components. And for the chart rendering, so I use the canvas.js. So it can generate many charts with the data entered by the user. They can show the bar chart like show in the right here. They can show the line chart, and show the pie chart, etc. Also, they can have multiple configurations such as the animation. That means when the chart is loaded, the data will show accordingly. And they can have different legends and have different titles. Lastly, will be the sizable website. So I designed the website to be sizable because we want to use the browser website in our mobile device. So on the left side of the photo is a normal desktop view of the page. It will show all the information here. On the right hand side is the mobile view of the website. So when the user need to access the sidebar, the tier 1 on the desktop page, so they need to click the three dash icon on the top left corner. So the sidebar will pop up and let the user to go to different pages. Also, the element will also be resized, such as in the top photo, the input field of the name, device, and the add device button are in the one row configuration. However, in the mobile view, the three elements will be stacked into 3 rows instead of one for the user friendliness for the web page.
So thank you. At the end of the presentation, I will going to talk about the schedule of the whole project and the budget of the whole project. So the whole project can be divided into the 3 stages. The first stage is the preparing stages. We are doing the research on the IoT and preparing what we are going to do and decide what we are going to do, and we prepare a lot of things like the proposal and the technical specification. So for the second stage, which in the between the January to the April of the 2020, we are going to we have developed the platform design and for the first 3 weeks, and then we are going to we did the hardware implementation and the software implementation. After that, we have testing our system and perform the system integration, and finally we have prepared the final report and the final presentation at the final stage in the April of 2020. So here is the detail what we have done in this year. So for the first 3 weeks, we have to do the platform design, and then for the middle of the semester, we have do a lot of stuff like the hardware implementation and the software implementation. Like we have do the sensor, we have adjust the hardware, and we have designed a database and our web application. So in this project, we have total spent 230 Hong Kong dollar for buying the 2 current sensor and 1 development board and the microcontroller and the waterfall sensor. So I think this is the end of our presentation. Thank you, and feel free to ask if you have any question.